Bismillah, alhamdulillah, wassalatu wassalamu ala rasulillah. This is the second conic section, section 10.2, the hyperbola. The second conic section is the hyperbola. Well, what is the definition of the hyperbola? Hyperbola is the set of points in a plane, the difference of whose distances from two fixed points called foci is constant. If you remember that the definition of the ellipse was same definition, but instead of the difference, we had the sum. Instead of the difference, we have the sum. So you can expect that if you remember the equation of the ellipse was x squared over a squared plus y squared over b squared equals 1. Now here we will not have plus, we will have minus. All right. But you have to understand the terminology now. Where are the foci and what is the graph of the hyperbola? This is the graph of the hyperbola. The foci are here inside the hyperbola, two foci. This is the center, which is we will start in this video with center 0, 0. So the center 0, 0. The distance from the center to the focus is again, we will call it C. And the distance from the center to the vertex is called A. So this is now the vertex. There are two vertices. You can see that the center C is greater than A in this case of the hyperbola. The vertices then has coordinates A0, negative A0, and the foci C0 and negative C0. And this axis that's connecting the two vertices and the foci lies on this axis is called the transverse axis. So the length of the transverse axis is 2a. So a is always, you find it from the transverse axis. The distance from the center to the vertex, that's always a. The distance from the center to the vertex is always a. So we will have two kinds of hyperbola also. If the transverse axis is horizontal like this, we will call it a horizontal hyperbola. And the equation, if you use the definition that this is the point B, it lies on the hyperbola if the difference between P and F1 and P and F2 equals to constant. So P distance P F1 minus distance P F2 is equal to a constant. So the equation of the hyperbola, if you use this definition, you will find that the equation is like this. Similar to the equation of the ellipse, but instead of plus, we have minus. But now A, B are different here. In the hyperbola, A is the distance, as we mentioned, from the center to the vertex, always. Here also A is the distance from the center to the vertex. This means that this is a horizontal hyperbola. This is a vertical hyperbola. The transverse axis here is vertical. This would be the graph. This is a horizontal hyperbola. The distance from the center to the vertex is A. This is A. The length of the transverse axis is 2A. And here the vertical hyperbola. We call it vertical because the transverse axis is vertical. This is the transverse axis between the two vertices. This distance from here to here is A. The distance from the center to the vertex is always A. So there is an important point here also. There is no specific relation between A and B. We will find out where is B. B somewhere here in this case, but up to where, and B here is up, but up to where, we will find out. But A here could be greater than B, or B could be greater than A, or A could be equal to B. There is no specific relation between A and B, like in the ellipse. In the ellipse, A is always greater than B. Here, it is not the case. So how to find out from the equation that this is a horizontal hyperbola and this is a vertical hyperbola? Always A, the distance between the center and the vertex, is below the positive coefficient. So x square here has positive coefficient, so a square below x square. Y square here has positive coefficient, so a square is below y square. So a square always have a positive coefficient, okay? Whether it is horizontal or parabola, a square always written in the beginning, in the first term, not like the ellipse. And so if you have x square positive, then the parabola opens right and left. If you have y square positive, then the hyperbola, the hyperbola opens up and down, and it's vertical. Here it is horizontal. A c square here is greater than a c is greater than a and b. So c square would be equal to a square plus b square. Also, this is different than the ellipse. In the ellipse, a square is c square plus b square. So you need to understand the graph and the terminology and the meaning of a, b, c here and there. This will help you to differentiate between ellipses and hyperbolas. Find the vertices and locate the foci for each of the following hyperbolas with the given equation. How do you find out that it's a hyperbola? There is a minus sign. And a here is what? Is 4 immediately. A square is the positive one, and b is 3. If you want to sketch the graph of this hyperbola, we will talk about the graph later. But the center also is 0, 0. There is no h and k. Is it a horizontal or vertical? X square positive, so it's a horizontal hyperbola. So the center is 0, 0, and 4 units to the right, 4 units to the left, because 16 is below x square, and the graph would be like this. This would be the graph of the hyperbola. So what do we need to find? Vertices. These are the vertices. So the vertices are positive 4 and 0, and negative 4 and 0. These are the vertices. What about the foci? Well, c square, you add here 16 plus 9. You don't subtract. 16 plus 9 is 25. So c is 5. So the foci are here. And foci has coordinates plus or minus 5 and 0. So this is the answer. So he needs the vertices and the foci. Here y square is positive, and the center is 0, 0. Below y I have 9, so I go 3 units up. And here are the vertices. So the vertices are 0 and positive and negative 3. The foci are here. C square is the sum 9 plus 16. So C is 5. and the foci will have coordinates 0, plus or minus 5. So this is 4, this is 5. 4, this is 5. These are the two foci. Find the standard form of the equation of the hyperbola with foci 0, -3, 0, 3, vertices 0, -2, and 0, 2. This is the second type of questions. If the foci, let me start with the vertices. If the vertices 0, 2, 0, -2, then the hyperbola opens up and down. And then I have y square minus x square equals 1. And the center is 0, 0, because the center is in the middle. Now the foci are here. The distance from the center to the vertex is a, so a is 2. And c is 3, because the distance from the center to the focus is c. b square would be c square, which is 9, minus a square, which is 4, so it would be 5. A square is always here with the positive. So a is 2, a square is 4, b square is 5. Notice here, b square is greater than a square. That's no problem with the hyperbola. It happens, okay? There is no specific relation between a and b. Here also, a is less than b, while here a is greater than b. We could have a equals to b, there is no problem. Okay, now after we talk about the asymptotes, we will talk about the graph, because the graph depends on the asymptotes. This rectangle is called the fundamental rectangle. Okay. And the diagonals of this rectangle are the asymptotes. There are asymptotes. The graph approaches the asymptotes. Okay. So these are the two asymptotes. And what would be the equations of the asymptotes? They are straight lines. So the equation, and they pass by the origin. So the equation of the asymptotes would be y equals mx, usually plus b, the y-intercept, but the y-intercept here is 0 because the graph passes by the origin. So the equation of the asymptotes y equals mx. And I have two asymptotes, one of them with positive slope and one of them with negative slope. So I'll have two asymptotes. How to find the slope of the asymptote? We'll look here. This is the line, the asymptote. This is the change in y. This is the change in x. The slope is the change in y over the change in x. The change in y is given by this distance, which is b. And this distance is a. So it's b over a. So the asymptote for the horizontal hyperbola has the equation y equals b over ax, and the other one y equals negative b over ax. And for the vertical hyperbola, a over b, negative a over b. Because now here, this is a and this is b. The change in y here is a, the change in x is b. Anyway, you can remember the equation of the asymptotes by always how to find, is it b over a or a over b? You always divide what is below y by the one below x. So here, b over a, while here, a over b, because a square is below y square, while here b square is below y square. So these are the equations of the asymptotes. You can also find the equation of the asymptotes in another way if you like. You can replace 1 by 0. You can replace 1 here by 0. This is another way. I gave you two ways. Use whatever you like. And you solve this equation for y. You will get the asymptotes. To solve it for y, you take this to the other side. So I will have y square over a square equals x square over b square. And to solve it for y square, I will have y square equals a square times x square over b square. So y would be plus or minus a over bx. And this would be the equations of the asymptotes. So do whatever you like. Either divide what is beneath y by what is beneath x, the square root of course, or replace 1 by 0 and solve for y. By this you will get the equations of the asymptotes. And now you can see b here is the distance from here to here. Okay, so this fundamental rectangle, the length of this fundamental rectangle is 2a, length or maybe length, maybe width, 2a, and the width is 2b. Okay, so you can talk about the area of this rectangle if you like. The area of this rectangle would be 2a times 2b, so 4ab. Okay, this distance is 2b, this is 2b, and this is 2a. The distance is 4ab. You can find the perimeter, the perimeter of the rectangle, whatever you like. All right. You can talk about the endpoints of the rectangle. These 4 endpoints, I can find their coordinates. This point has coordinates b and a, for example. Okay, you can find all of them. So these are the asymptotes for the horizontal transverse axis. For the horizontal hyperbola, b over a would be the asymptotes. For the vertical, y square is positive, a over b would be the equations of the asymptotes. So to graph a hyperbola, we start by the center, in fact. Okay, we find the center because he said here centered at the origin, so we know that the center is 0, 0. But in the next video, we will talk about center HK. So you find the center first. Once you have that the center is 0, 0, locate the vertices A. Okay, and then draw the rectangle, the fundamental rectangle. You go A units and B units to draw the fundamental rectangle. Okay, using dashed lines. And then you draw the diagonals of the rectangle. These would be the asymptotes. And then you draw the hyperbola. Okay, let us apply these steps. I need the center first. Well, the center here is, it's clear that it is 0, 0. There is no x minus h, y minus k. If I ask you what is, immediately I can start drawing without talking about a, b. The center is 0, 0. Okay, this is x squared, 5 units to the right, 5 units to the left. 16, 4 units up, 4 units down. And draw dashed lines. Draw the rectangle. This is the fundamental rectangle. This is the fundamental rectangle. Okay, so I have, where are the vertices? X squared is positive, so these are the vertices here. These are the vertices. This is the transverse axis. Okay, draw the diagonals of this rectangle. These are the diagonals, the asymptotes. These are the asymptotes. The diagonals pass by the endpoints of the fundamental rectangle and the center. That's it. Now draw the hyperbola. This is the vertex and it approaches the asymptote. It approaches the asymptote. You should approach always the asymptote. Don't go away from the asymptote. So this is the graph of this hyperbola, as simple as that. Now, what are the equations of the asymptotes? Well, the equations of the asymptotes, y equals plus or minus 4 over 5. B over A. What is A of B over A? What is below Y over what is below X? The square roots. 4 over 5X. These are the equations of the asymptotes immediately. The foci, C square is 25 plus 16 because C is greater than A and B. So start from the center and the foci would be here on the transverse axis. So it would be the foci would have coordinates plus or minus square root of 41 and 0. And the vertices here, if you like, are plus or minus 5 and 0. Okay, these are the vertices. Graph and locate the foci. What are the equations of the asymptotes? The equation here is not written in the standard form. So as we know, we divide by 36 as we did in the ellipse. So I'll have y square equals y square over 4 minus x square over 9 equals 1. To graph the hyperbola, the center is 0, 0. 2 units up and down below y. 3 units right, left below x. Draw the fundamental rectangle. Draw the asymptotes. Now, where are the vertices? This is y square positive, so the vertices are here. Draw the hyperbola and become closer to the asymptotes. These are not lines, these are curves. So try to draw curves. The foci should be here on the transverse axis. Let me write first the equation of the asymptotes. Below y I have 4, so I take 2. Below x square I have 9, so I take 3. These are the equations of the asymptotes. And for the foci, c square is 9 plus 4, that's 13. The foci would be here now. So the foci has coordinates 0 plus or minus square root of 13. Now find some exercises. Find the vertices and locate the foci of each hyperbola with the given equation. Then match each equation to one of the graphs that are shown and labeled A to D. Okay, number 1. A, this hyperbola opens right and left because x squared is positive. So either it is B or C. Sorry, B or D. A, the distance from the center to the vertex is 2. So here the distance is 2, while here the distance is 1. So the graph, the graph of number 1 is part B, and also I have x squared here over 1. So the graph of number 2 is D. While question 3, I have 2, it opens up and down, both 3 and 4 up and down. So either A or C. But here 2 is the distance from the center to the vertex. And that's part A. So this has graph A and this has graph C. As simple as that. If I want to find the vertices and the foci, for example, for the first one, well, I can find them from from the graph. But I have the vertices, but I don't have the foci. But I can think of it. 2 is the distance from the center to the vertex. And the vertices here are on the transverse axis, and the transverse axis is horizontal because this is x squared. So the vertices would be plus or minus 2 and 0. The foci also would be on the transverse axis, so horizontal. But c square, what is c square? 5. 4 plus 1, 5. So the foci would be plus or minus square root of 5 and 0. For 2, the distance from the vertex to the center is 1. So the coordinates of the vertices are 0 plus, sorry, they are horizontal. This is a horizontal. This is a horizontal hyperbola. So the vertices are on the x-axis. So plus or minus 1 and 0. The foci would be also the foci here are on the x-axis. And I'll have 1 plus 4, 5. So plus or minus square root of 5 and 0. For 3, this hyperbola is vertical. So the vertices and the foci lie on the y-axis. The distance from the center to the vertex is 2. So the vertices has coordinates 0 plus or minus 2. While number 4, 0 plus or minus 1. The foci 4 plus 1 is 5, 4 plus 1 is 5. And both are vertical. So the foci lie on the y-axis. So the coordinates are 0 and plus or minus square root of 5. I hope you understand the subject. Find the standard form of the equation of each hyperbola satisfying the given conditions. I need here the equation. Well, as usual, I'll graph the information. 0, 6. This is what? This is the focus. So C is 6. And because of 0 and negative 6, so the center is 0, 0. The center. The vertices 0, 2. So A is 2 because the distance from the center to the vertex is A. So here is the vertex and the graph is like this. And the foci are inside the hyperbola. So what kind of hyperbola is this? Vertical. So the equation is y squared over minus x squared over equals 1. Below y squared, 2 squared, which is 4. Now what about b? B squared is c squared minus a squared. So b squared is 32, and we put it below x. So that's the answer. That's the equation, the required equation. Here, the foci 7, 0 and negative 7, 0. So the center is 0, 0. And this is one of the foci. So C is 7. The vertices are here. So A is 5. So B square is 49 minus 25, and that's 24. And these are the vertices. So the parabola opens right, left, and this is a horizontal hyperbola, sorry. So the equation horizontal, so we start by x. So this is x squared over minus y squared over equals 1. Below x, 5 squared, a squared, and here b squared, and this is the equation of the hyperbola. Well, here the end points of the transverse axis. What are the endpoints of the transverse axis? They are the vertices. So this is the vertex and another vertex here. So the center is again 0, 0, and A is 4. Good. The asymptote y equals to 2x. All right. If the vertex is here, so this is a horizontal hyperbola. So the equation is x squared over minus y squared over equals 1. And what is below x is a squared. So 16 here. And here I have b squared. All right. What is the definition of the asymptotes in this case? The asymptotes has equations plus or minus b over 4. Okay. Square root of this, what is beneath y, over what is beneath x. So b over 4, of course x, is equal to 2 because we have one of the asymptotes. So this is the slope. So b over 4 is 2. This means that b is multiply cross multiplication is 8. So the equation is x squared over 16 minus y squared over 8 squared. That's 64 equals 1. Use vertices and asymptotes to graph each hyperbola, locate the foci, find the equations of the asymptotes. The center is 0, 0. 4 units to the right and left, 5 units up and down. These are the vertices. You can draw the fundamental rectangle. And then the asymptotes. This is always the case. These are the vertices. Sketch the graph of the hyperbola. Make it, let the graph approaches. Approaches the asymptotes. Come closer to the asymptotes. So what are the equations of the asymptotes? Y equals plus or minus 5 over 4x. What about the foci? C square is 25 plus 16. C is 41, square root of 41. Where will be the foci here? So the foci has coordinates plus or minus square root of 41 and 0. Of course, the vertices have coordinates plus or minus 4 and 0 if you want, if he asks about it. The same, we start by the center. The center is 0, 0. From the center I go 5 units up and down because beneath y square. Beneath x square I have 64, I go 8 units right and left. And I draw the rectangle, the fundamental rectangle. And then the asymptotes. Straight lines. Where are the vertices? Y square, so the vertices are here. Also here. So this is the graph of the hyperbola. Equations of the asymptotes 5 over 8 plus or minus below x, below y over below x. And c square, just add 25 plus 64. That's 89. And now the vertices are here on the y-axis. So the coordinates of the foci are 0 plus or minus square root of 89. Well, I have 1 here, but this is 9. I should write it in the standard form. How? Y square over this 9, I write it 1 over 9. Remember, 9 is 1 over 1 over 9 minus x square equals 1. What is the center? 0, 0. 1 over 3 units up if this is 1 and this is negative 1. And 1 over 3 units down. 1 unit right and 1 unit left. The fundamental rectangle, the asymptotes. Where are the vertices? Y square, the vertices are here. So this is the graph of the hyperbola. Equations of asymptotes. Now below y, I have 1 over 3 over 1. So it's 1 over 3x. Okay, these are the equations of the asymptotes. C square is 1 plus 1 over 9. So it's 10 over 9. So they are here. Okay, so 0, the coordinates of the foci 0 plus or minus square root of 10 over square root of 9, which is 3. So these would be the coordinates of the foci. Another question. 100 divided by 100, it should be 1. X square over 100 over 4 is 25. 100 over 25 is 4. 100 is over 100 is 1. 0, 0. Center. 5 units right. 5 units left. 2 units up. 2 units down. Fundamental rectangle. Asymptotes. Where are the vertices? Horizontal. So the vertices are here. These are the graphs of the hyperbola. Excuse my graphing, my sketching, but I think you know the idea. The equations of the asymptotes would be plus or minus 2 over 5 below y over below x. C square is 29. Where are the foci here? So the coordinates of the foci are plus or minus square root of 29 and 0 because the foci lies on the x axis. Find the standard form of the equation of each hyperbola. This is a horizontal hyperbola, so the equation is x squared minus y squared equals 1. Also the center is 0, 0. X below x I have how many units here? 3. Square it. And here I have 2 up to the fundamental rectangle. Square it. So this is the equation of the hyperbola. Center 0, 0. Vertical hyperbola. So y squared minus x squared over equals 1. This is y. How many units? 5 up to 5. Okay. 25 squared. X up to 3. 3 squared is 9. So this is the equation of this hyperbola, and I'll stop here. And in next video, we will talk about hyperbolas with center HK.